Hi, Jason Knott with CE Pro, and today we are talking about the ever-changing landscape of video distribution and video. And I'm here with the people from Zigen Corp. Hi, everybody.
Hey, Jason.
Hello, Jason.
Hello.
With me today are Ed Delalian, the owner and lead engineer. Hi, Ed.
Hey, Jason. How are you?
Also with me is Larry Wichonko, senior hardware design engineer. Hi, Larry.
Hello, Jason. Good morning.
And last but not least, of course, is Vanessa Zitzman, sales and marketing. Hi, Vanessa.
Hi, how are you doing?
I'm doing great. Let's jump right into this. What are the advantages of AV over IP versus analog installations? Larry, you want to take that?
Sure, I'll take that answer. AV over IP has the distinct advantage of being able to use an existing network infrastructure to be able to extend, distribute, as well as cross-point AV. One advantage of AV over IP also is, just like our IP logic system, it's a multi-purpose device as well. It has features such as video wall and multi-view, whereas traditional systems are pretty much single-purpose type devices. Traditional equipment also tend to be bulkier and more expensive to use.
Let's talk about the ability to expand a system. With AV over IP, is it easier than an analog system? If you want to expand that system, is it modular in some way? Is it more easily configurable?
It is absolutely much easier to expand. If an infrastructure right now requires additional equipment, such as more monitors or more sources, then it's just a matter of getting more encoders and decoders for each one of those endpoints. As long as you have the available ports on your routers, it's easy to expand the system. In a traditional analog system, if your AV cross-point switch is all used up, you basically have to throw away that audio matrix and buy a bigger system. Whereas with AV over IP, if you run out of ports on your router, you can simply get another one and expand on that to be able to scale your whole system. And one of the largest advantages of expandability with AV over IP would be like for large enterprises, airports and hospitals, where they might be distributed over different campuses or even different floors of a building. If an AV over IP is already set up in those facilities, you can easily cross-connect those campuses using link aggregation or cascading with, that's built into a lot of these routers. You can't do that with traditional systems. You're basically locked in.
And I also want to add one more thing to that. When it comes to AV over IP, we're able to distribute the audio as well. So we could do AES67, ST2110. We're backwards compatible with Dante, Ravina, Livewire. And we're AES 128 certified as well when it comes to AV over IP distribution. So all your audio distribution, video distribution, KVM, USB 2.0, serial IR, we cover it all. So it helps eliminate a lot of the installation griefs that the integrators face out in the real world environments.
Speaking of that, what's the infrastructure wiring topology difference between an analog system versus an AV over IP system?
Well, when you look at it from an integrator standpoint, there really is not much difference between traditional versus AV over IP. In a traditional system, you may have your sources and your AV equipment, your AV matrix switches, in a central closet or in a rack system. Your TVs are extended out and located in different rooms. In an AV over IP solution, it's essentially the same thing. Your sources with their encoders are installed in an equipment rack where your network switches are, and it's a star topology that are connected to other endpoints in other rooms.
Ed, let me ask you this. We've seen this progression in displays from 1080p to 4K. Now we see 8K, and we hear talks of even 10K. Does an AV over IP allow an integrator to mix and match these different display technologies?
Absolutely. It does vary from manufacturer to manufacturer, but when it comes to our AV over IP, we could actually, we're designed to work in a mixed display environment, anywhere from 480i all the way up to 4K 6444 with or without HDR. So that's the beauty when it comes to AV over IP. It's got independent scalers built into it. So you're not limited, or you're not fixed to a cross-point switch that you have to add or subtract scalers to make that system work. With the AV over IP, it's a lot more flexible.
Let's talk about another topic that I hear from integrators quite frequently, and that's a 1G versus a 10G AV over IP system. What are some of the differences, pros and cons?
Okay, well, they both have their own place. When it comes to commercial environment, let me just back up a second. You have to look at the application first. What is the application calling for? If it's just a standard bar and restaurant that you're gonna be distributing 1080p content, 1G is perfect. But when you want that uncompressed information or slightly less compressed information, accurate information with Dolby Vision and so on, 10 gig is more preferred, because 10 gig is not going to compress that information. And when it does, it's only going to compress from 4K 30 to 4K 60. So if you're after the quality, 10 gig is going to be much more desired than the 1 gig. They both have their own place, but when you're talking about the high-end video distribution or residential application, 10 gig is more desired. And I would pick 10 gig over 1 gig any day.
To expand on what Ed was talking about, the 10G network infrastructure, you'd use that on a high-end home theater system, for instance, or maybe large venues like stadiums and bars and restaurants, 1080p. So it's 1G.
You also want to use your 10 gig solution in situations where you know that the client, the end user, is going to want to continue to expand. So you don't want to limit your end user to a specific system. You want to have that bandwidth available. And in those cases, you definitely want to also use the 10G.
And I also want to add about the compression. Your traditional 1 gig pipeline, or any sort of video distribution that's taking place over 1 gig pipeline, in most cases, they're going to be compressing, 99% of the time, they're going to be compressing 60 to 1, whereas 10 gig does not compress anything up to 4K 3444, and the only compression takes place from 4K 30 to 60, and it's 1-to-4 compression. And there are different methods of compressing information. There is color space conversion, and then there is the display stream conversion. Or compression, I'm sorry. So we utilize the display stream compression instead of color space conversion. So the picture end result is going to be much better on a 10 gig platform versus 1 gig platform.
Ed, let me stay with you on another area of concern that I hear from integrators quite often, and that is fiber versus copper. What should they be using out there for their AV over IP networks?
Well, not all AV over IP platforms will give you the pipeline to utilize copper or fiber. When it comes to our AV over IP, we have both engines built into it. We have copper or fiber. You could pick and choose depending on the distance. Obviously, category has some limitations. 100 meter or 330 feet on a Cat 6A, that's going to be your limitation. But with our AV over IP, we have the fiber engines built into it. So if you're surpassing that distance limitation of 330 feet, you could just plug in the fiber. So with us, you could go up to 30 kilometers on a fiber.
Yeah, Larry, are there any other pros and cons on fiber versus copper?
There is, obviously, copper is more durable, whereas fiber is a little more delicate. But in terms of EMI, it's also a lot less in fiber than there is in copper.
I also want to add one more thing to that. When you're utilizing copper, you could utilize the PoE aspect of things. Our AV over IP also has the PoE enabled. But when you're going to fiber, then fiber obviously requires power supply on the receive side. So there's an advantage and disadvantage to both.
All right, let's help out the integrators in terms of what they should be looking for in their HDMI. You know, we've been waiting for quite a long time for the final compliance test specification for HDMI 2.1. What should they be looking for? Is it something they should be asking about? Is it labeled? What's the direction and help for them in terms of while they're waiting for this 2.1 spec to hit the books?
Well, the test specifications have not been released. And if a manufacturer is claiming that the product has been certified, that's just going to be, we call it marketing lies or honest lies. So you always want to wait for that test specification or the test houses to be able to test the product. We know some of the key features when it comes to 2.1, we could support eARC, so on and so forth. But to actually have a certified product, it's not available yet.
So without that certification in place, you mentioned eARC and some of the things that you guys are doing. What should they be looking for or asking their supplier when they're looking for their HDMI cable?
Well, that's a good question. There is no one way of answering that. It's all about reputation when it comes to products. So if the company is reputable selling the product and you trust them in delivering on the promises, that's probably one of the better ways of looking at the product and speccing that in without any certification currently. Also, making sure that their 2.1 product is transparent. That means it doesn't have a choke on the performance. It's not fooling the EDIT. It's in thinking that it made a hard connection with display. What we found in our testing with third-party companies or manufacturers claiming 2.1 cables and whatnot, we found that these cables actually insert an EDIT table to fool the source in thinking that it made a hard connection with display. And that's false. And you want your cable to be a medium. You want it to be transparent. You want that EDIT information to be sent from display back to the source so they can make a handshake. And the desired information is sent from point A to point B. So again, it's all about transparency. And we actually make great tools that embedded into our platforms, cross-point switches and whatnot. If you plug in the 2.1 cable, if you will, if you're able to see the EDIT coming from the display, we could monitor that. And if you're seeing that EDIT come through, then that means the cable is for the most part, it's doing what it said it's supposed to be doing. But in our testings, we found that a lot of these companies actually put a choke on a performance and fooled the EDIT in thinking that it made a hard connection with display.
I think one of the best things an integrator can do is ask questions. So when they go in to purchase a cable, to ask the manufacturer or the distributor, what exactly am I getting with this? If it's not officially certified, then what does this mean? And see what they say.
One thing to really take a look at with these cables, I'm talking about these HDMI cables that are, they call HDMI 2.1 compliance. HDMI stipulates that there should be ultra high speed certification labeling on it with a QR code for traceability. So I would be very leery in using inexpensive HDMI 2.1 pouted cables. Just test it.
All right, Vanessa, let me start this question with you. We just kind of talked about the lack of a test specification and the trust that you have to have in the supplier that you're dealing with. Zigen makes DACs, you make cabling, you make extenders, you make this AV-over-IP distribution equipment. What is the advantage for an integrator to be using a single supplier such as Zigen that has a single ecosystem?
I think a single ecosystem is really important, especially when it comes to Zigen. Our entire product line was built and designed by an integrator. Ed used to be an integrator, so all of our products were designed to eliminate problems that he was finding in the field and that our engineers are finding in the field. So when you have a strong backbone, when you're using a product like Zigen, and we are, there for your cabling needs, we've got the audio component, you're using our matrices, you're using, our extenders, that because you're using all of our products and you're using them together, the backbone of your installation is going to be strong. When something goes wrong, you're calling one number instead of 15 numbers trying to figure out what's happening. And then when you call us, because we're designed and engineered right in the United States, you call and talk to one person, and most of the time it's going to be Ed or Larry. And I think that speaks for itself.
We've had numerous tech support calls where with our built-in diagnostics in some of our systems, we're able to actually log in with the integrator on site on the job site, be able to log in through TeamViewer and diagnose what is happening on that job site installation. That's a service that we've done for years. Ed?
And we actually find problems not associated with Zigen. And, you know, it's surprising. Most of our dealers call and say, hey, Ed, I walked into a job, or Larry, I walked into a job. It's not your product, but you guys do such a wonderful job helping us out.
It sounds like it's not just the convenience from a tech support standpoint or a compatibility standpoint, but think of the convenience of just isolating in on a single supplier versus maybe having to source product from 4 or 5 different sources. And we're talking right now, it's so important for integrators to be as efficient as possible.
Well, when you look at it in several different ways, you can look at it in a monetary way. You're going to spend less time on the phone. You're going to spend less time in billing, less time invoicing. There's just a whole lot of different things. And when you have a strong manufacturer like Zigen, you know, we're going to take care of a lot of that stuff for you. We're going to make sure that, you know, we're a strong support for you. And when you're using our products, you have access to us.
All right. Ed Dalalin, Vanessa Zitzman, Larry Wichongo from Zigen Corp. Thanks for joining CE Pro today.
Thanks, Jason.
Thank you very much, Jason.